Hello dear learners, I am Dr. Nishant Yadav. Welcome to this lecture of the course on Essentials of Surveying, Application and Techniques. In this class, we will solve numerical based on the topics that are already covered. So it is going to be a fun and exciting class. Hope you all are ready with your calculators. We'll start with a basic question. So the coordinates of 2 points A and B are given as you can see in the table. It is similar to x and y coordinates, but since we are locating points northing and easting, it will make more sense if we consider coordinates in north, south, east, west coordinates. The point A coordinates are 500.25 and 640.75, whereas coordinates of B 840.78 and 315.60. So if the values are positive, that means they are on the northeast quadrant, and we have to find the length and bearing of the line AB. So it is a good practice to sketch the coordinates of the readings that are given. So the coordinates northing and easting of point A is given as 500.25 and 640.75. To plot A on the map, take 500.25 units along the north axis and then 640.75 units along the east axis. Similarly, you can locate the point B whose coordinates are given. As we can see, both the points A and B are having positive values of north and east coordinates. This means that both the points lies on the first quadrant, that is northeast quadrant. Now to calculate the length AB, let small l be the length of line AB and theta is the reduced bearing of line AB. Remember, we will always make use of reduced bearing for calculating latitudes and departures. The latitude of AB is equal to the difference between the north coordinates of point A and B. So it is equal to 840.78 minus 500.25, which is equal to 325.53. Similarly, for the departure of AB, it is actually the difference between the east coordinates of point A and point B is equal to 315.60 minus 640.75. The value comes out to be negative 325.15. Since the latitude is positive and the departure is negative, that means that point B is towards the left or westward of the point A, and the line AB is inclined towards the northwest. So as the latitude and departure is calculated, now we can calculate the angle theta, which is equal to tan theta is equal to departure by latitude, and the values are 325.15 divided by 340.53. The angle theta works out to be 43 degree and 41 minutes. To calculate the length of line AB, the formula is under root L square, that is summation of all the latitudes plus square of summation of all the departures. So as you can see on the screen, formula is under root of sigma L square plus sigma D square. The length works out to be 470.834 meters. Now when we draw the meridian at point A and draw the line AB, it will be inclined at 43 degree 41 minutes from north towards the west direction. The reduced bearing of line, as we have seen, it is north 43 degree 41 minutes west. If we convert this into whole circle bearing, that is angle will be measured or the bearing will be measured from north in clockwise direction. So it is 360 degree minus 43 degree 41 minutes, and it comes out to be 316 degree and 19 minutes. there is a check that is also associated with this. The check is the length of AB is already given in the question. We know that latitude of AB into secant theta or sec theta. So 340.53 into sec 43 degree 41 minutes will give you the length of line AB, which is equal to 470.879 meter. So it is approximately the same. So this correction you need to show at the time of solving the question. Coming to the next question, the bearing of survey lines PQ and QR are given as 18 degree 36 minutes for the line PQ and 60 degree 24 minutes for the line QR respectively. The coordinates of the ends P and Q are for P it is 300 northing and 400 meters easting, and for point R the northing is 1432.8 meters and easting is 1257.2 meters. In this question we have to find the length of line PQ and PR. The bearings of survey lines PQ and QR are given in the question, and the coordinates of the end points of P and R are also given. But we have to find the length of PQ and PR. So when we have the coordinates of the ends P and R, we can calculate its length and bearing. Then once the length of PR is calculated and plotted, we will draw a survey line PQ and QR as the bearings are given. Then we will find the length of PQ and PR. Let us first make a sketch of the coordinate readings as given. Point P will be plotted as 300 meters of northing and 400 meters of. For point P, 300 units will go along north axis and then 400 units towards the east axis. Likewise, we will plot point R also as per the coordinates given in the question. R is 1432.8 and 1257.2. As we can see, both the points P and R are having north and east coordinates. That means the points both P and R will lie in the first quadrant. Now we will find the length of PR. Bearing of line PR will be equal to, or the angle that will be given is theta is equal to 1257.2 minus 400 divided by 1432.8 minus 300. It is equal to 857.2 divided by 1132.8, and when we calculate the tan inverse of the above ratio, we will get theta as 37 degrees 6 minutes. As we can see, the latitude and departure both are positive. That means the line PR lies in the northeast quadrant, that is, or we can say it is inclined towards northeast. The reduced bearing of the line PR will be north 37 degrees 6 minutes east, and if we convert this value into whole circle bearing, it will be 37 degree 6 minutes. Now to calculate the length of PR, we can use the trigonometric equation. You refer to the figure that is being shown on the screen. Cos theta is equal to base upon hypotenuse. So the cos theta would be equal to the latitude divided by the length of member PR. We can cross multiply the terms, we will get the length PR is equal to latitude upon cos theta, and we know that 1 by cos theta we can write as sec theta. So directly you can use this formula. The length of line PR is equal to latitude into secant theta or sec theta. The value of theta is calculated as 37 degree 6 minutes. So the latitude that will come out to be is 1132.8. So the length of PR will be 1132.8 into sec theta, that is equal to 1421 meter. Suppose we are moving in a traverse A, B, C, D. The first station is A then followed by B and D and so on. The bearing of the line measured from station A to B will be designated as forebearing, and the bearing of the same line measured from B to A is designated as back bearing. Suppose the value of forebearing is less than 180 degree, then back bearing will be equal to the forebearing plus 180 degree, and in case forebearing is greater than 180 degree, back bearing will be equal to forebearing minus 180 degree. So remember this simple equation, back bearing is equal to forebearing plus minus 180 degree. The whole circle bearing of line PR as calculated as 37 degree 6 minutes, and the bearing of line PQ is already given in question as 18 degree 36 minutes. We draw a meridian at station P and plot these lines. We can see that the interior angle RPQ will be equal to bearing of previous line minus bearing of next point. Suppose we are at station P, so the next station would be Q and the previous station would be R. So the bearing of previous line will be PR and forebearing of next line would be PQ. So the value is 37 degree 6 minutes minus 18 degree 36 minutes. It comes out to be 18 degree 30 minutes. Now moving to next station, that is Q. Bearing of line QR is 60 degree 24 minutes, that is forebearing of the next point. From Q the next point is R or line QR. Bearing of the line PQ is already given as 18 degree 36 minutes, that is measured from P towards Q. But since we are in station Q, we need the bearing QP, that is the back bearing of line PQ. So since the value of forebearing of previous line is less than 180 degree, for the bearing of back bearing of line PQ, we need to add 180 to it. So the back bearing of line PQ would be 180 degree plus 18 degree 36 minutes. It is equal to 198 degree 36 minutes. Since we are seeing that forebearing is less than 180 degree, in that case we add 180 degree. So the bearing of previous line QP would be 198 degree 36 minutes. Suppose we are at station Q, draw a meridian at station Q and plot these lines QP and QR. So the interior angle Q, that is angle RQP, is equal to bearing of previous line minus forebearing of next line. The bearing of previous line, as we calculated, 198 degree 36 minutes minus 60 degree 24 minutes, it comes out to be 138 degree 12 minutes. Now we will move ahead in the traverse. The next point will be station R. Bearing of line RQ, that is back bearing of line QR. The bearing of line QR is given as 60 degree 24 minutes, but since we are at station R, the bearing of the line RQ will be calculated by adding 180 to the bearing of same line, the forebearing of same line, that is 60 degree 24 minutes. It comes out to be 240 degree 24 minutes. Bearing of the line RP is required. Now we will refer to the figure that was drawn for station P. We can calculate bearing of line PR. The forebearing of line PQ plus the interior angle that was calculated at P. The forebearing of line PQ is given as 18 degree 36 minutes and the interior angle P as calculated was 18 degree 30 minutes. So the bearing of line PR, that is measured from P to R, is equal to forebearing of the line PQ plus interior angle at P, 18 degree 36 minutes plus 18 degree 30 minutes is equal to 37 degree 06 minutes. So the bearing of line RP, that is back bearing of the same line PR, would be, since the value is less than 180 degree, we will add 180 degree. The bearing of line PR would be 180 plus 37 degree 06 minutes is equal to 217 degree 6 minutes. So the interior angle R, that is angle QRP, will be calculated as bearing of previous line minus 4 bearing of next line, will be equal to 240 degree 24 minutes minus 217 degree 6 minutes is equal to 23 degree and 18 minutes. Finally, to find the length of PQ and QR, we will use sine rule. Draw a sketch with all the interior angles and sides. The value of PR is known as 1421 meters and all the angles are also known to us. Use the sine rule, that is PR by sine Q is equal to PQ by sine R is equal to QR by sine P. These ratios are equal to each other. When we substitute the values, we can calculate the values of PQ and QR. PQ is equal to PR into sine R by sine Q, and it will be equal to 843.22 meters. To calculate QR, which is equal to PR into sine of angle P, is equal to 679.49 meters. Next, the next type of question we will take up is on missing data, a very important topic for competitive exams, also referred to as omitted measurements. As you know, in closed traverse, all the lengths and directions are measured in the field so that the proper check can be made, and if required, the traverse can be adjusted. But sometimes it is not possible to take all the linear and angular measurements in the field due to some obstacles or constraints. Such measurements are called omitted measurements. Coming to the question, the following are the lengths and bearings of the sides of a closed traverse A, B, C, D, A, or just A, B, C, D. The lines, lengths and bearings of the lines are given as: line AB length is 78.2 meters, line BC length is 198 meters and bearings is 36 degrees for 24 minutes. Line CD, the length is 37.8 meters and bearing is 338 degree 48 minutes. The length and bearings of line DA are missing. So we have to calculate the length and bearing of the line DA. For this, we need to calculate the latitudes and departure. So for that, we require the bearings in reduced or quadrantal bearing system. So the step 1 would be to convert this whole circle bearing to quadrantal or reduced bearing. In whole circle bearing, all the bearings are measured from north axis, called as the meridian, in clockwise direction, and the values ranges from 0 to 360 degree. Whereas in quadrantal or reduced bearing, the bearings are either measured from north or from south, towards east or west. The values ranges from 0 to 90 degree and bearings are designated as per the quadrants in which the point or the line lies. So simply by drawing the sketch, we can calculate the bearings from one system to the another. So the whole circle bearing of line is 140 degree 12 minutes measured from north in clockwise direction. So the line is in southeast quadrant. The value is greater than 90 degrees, so the value is in southeast quadrant. Will measure the reduced bearing from north towards east. So simply subtract 180 minus 140 degree 12 minutes, we will get the reduced bearing of the line as south 39 degree 48 minutes east. The whole circle bearing of the line BC is 36 degrees 24 minutes measured from north in clockwise direction. So the line is in northeast quadrant itself. That means the reduced bearing system, it will be designated as north measured towards east. So the value of the bearing would be the same, and the reading measured from north toward east will be equal to north 36 degrees 24 minutes east. Coming to the next line, the whole circle bearing of line CD is 338 degree 48 minutes. Again it is measured from north in clockwise direction. The value is greater than 270 degrees but less than 360 degree. So the line is in northwest quadrant. And that means in reduced bearing system, it will be measured from north towards west. To get the value, subtract 360 from the whole circle bearing value, which will be equal to 360 minus 338 degree 48 minutes. It will work out to be north 21 degrees 12 minutes west. Moving ahead to the next line, that is calculate all the latitudes and departure. We have all the values of length of the traverse sides and reduced bearing of all the angles measured from the meridian north south. So we will find the length of latitudes of the lines from the known values of length and bearing. So the latitude AB is equal to its length 78.2 into cos of its angle, that is 39 degree 48 minutes. No need to write the quadrants here, only the angle value is sufficient. So it comes out to be minus 60 degree 0.08 minutes. So since it is latitude, the negative sign indicates that line is southwards. Latitude of BC is equal to 198 cos 36 degree 24 minutes. The value comes out to be positive 159.37 meters, and the positive sign indicates that the value is towards north. Latitude of CD, length is 37.8 multiplied by the angle, that is cos 21 degree 12 minutes. The value comes out to be plus 35.24 meters. It is again positive, that means the value is towards north. Latitude of line DA is equal to L cos of theta. Since the latitude is not known to us, length is not known to us, even the bearing is not known to us. So for the moment we will write it as L cos of theta. And we know that the algebraic sum of the latitude should be equal to 0. So we will add all the terms. So L cos theta plus 35.24 plus 159.37 minus 60.08, it is equal to L cos theta plus 134.53. The traverse being closed, the summation of all latitude should be equal to 0. So we will equate this term equal to 0 and we will get L cos theta equal to minus of 134.53. That means negative value means it is towards south. Now we will find the departure of the lines from the known lengths and bearings of the line. Departure of line AB is equal to 78.2 into sine of angle. It is equal to 50.06 towards east. Departure of BC would be 198 into sine of angle 36 degree 24 minute. It comes out to be positive 117.49 towards east. Departure of line CD would be equal to 37.8 into sine of angle 21 degree 12 minutes, and departure of line DA would be, again length and bearing both are unknown, so we will keep it as unknown L sine of theta. So again we will do the algebraic sum of all the departures considering the sine. L sine theta plus 50.06 plus 117.49 minus 13.67, it comes out to be L sin theta plus 153.88. For a closed traverse, we know that sigma d, that is summation of all departures, should be equal to 0. So L sin theta would be equal to minus 153.88. Negative means it is towards west. Since the latitudes and departures of line DA are both negative, therefore the line DA lies in southwest quadrant. Now the tan theta, which we know, is equal to departure divided by latitude. Departure value is 153.88 divided by 134.53 is equal to 1.1438. So when we take the inverse of it, we get theta as 48 degree 50 minutes. This is the reduced bearing. So the quadrantal or reduced bearing value of the line DA would be S 48 degree 50 minutes west. Converting this value into whole circle value, since it is less than 180, we'll add 180 to it. So the whole circle bearing would be 180 plus 48 degree 50 minutes. It is equal to 228 degree 50 minutes. And to calculate the length of line DA, which is equal to square root of summation of latitudes plus square of summation of departures. So solving it, we will get the length of DA as 204.4 meters. We will have a check also. The latitude into sec theta should give the value, should give us the value of the length of member DA. So it is equal to 204.37. From departure also we will calculate the same. Departure into cosec theta is equal to 204.39. So these are the values of line. Moving ahead, the prerequisite for the next question is the concept of magnetic declination, which you have studied in the compass surveying. The magnetic declination is the angle between magnetic north and true north. Declination is positive when this angle is east of the true north and negative when it is to the west. Magnetic declination keeps on changing over time and location. Declination is positive, or it is considered positive when this angle is towards east of the true north. You can compute the true bearings from a magnetic bearing by adding the magnetic declination to the magnetic bearing. This principle works good as long as we follow the convention that degrees west are negative. Coming to the next question, the following are the length and bearing of the sides of a closed traverse A, B, C, D. The lengths are given in meters and the bearings are also given. So the length is equal to 235 meters. The bearing is given as 343 degree 54 minutes. For line BC, the length is 317.5 meters and bearing is 87 degree 52 minutes. For the next line CD, it is 215 meters and 172 degree 42 minutes. For line DA, the length is 281 meters 0.5 and 265 degree 14 minutes. The bearings are referred to the magnetic meridian. The value of magnetic declination that is given is 5 degree 32 minutes towards west. Now we have to convert the observed bearings to the true bearing and find the closing error. Solution. Since the magnetic meridian is 5 degree 32 minutes towards west of the true meridian and it is referred to as negative declination as per our sign convention. So in order to obtain the true bearings of the lines, deduct this value from the each observed value and then convert these true bearings to reduced bearing, and then finally we'll calculate the latitudes and departures of the line. To calculate the latitude and departure of the lines, we need the bearings in reduced bearing system. Given as the whole circle bearing of line AB is 338 degree 22 minutes, measured from north in clockwise direction. As we can see, the value is greater than 270 degree and is less than 360 degree. So the line is in fourth quadrant, that is northwest quadrant. That means the reduced bearing system will be measured from north towards west. To get the value of angle measured from north, we'll subtract 360 from the whole circle bearing given as 338 degree 22 minutes. So it comes out to north 21 degrees 38 minutes west. The whole circle bearing of line BC is 82 degree 20 minutes measured from north in clockwise direction. So the line is in northeast quadrant. The value is less than 90 degree. So it is in northeast quadrant itself. That means in reduced bearing system, it will be designated as north towards east, and the values would be the same as the both readings are taken from north towards the east. So the reduced bearing would be north 82 degree 20 minutes east. The whole circle bearing of line CD is 167 degree 10 minutes measured from north in clockwise direction. The value is more than 90 degrees but less than 180 degrees. So the line is in southeast quadrant. That means the reduced bearing system, it will be designated as south measured towards east. So to get the values, simply we will deduct the value by 180 degree. So the RB or the reduced bearing of the line CD would be 180 degree minus 167 degree 10 minutes is equal to south 12 degree 50 minutes east. The whole circle bearing of line DA is 259 degree 42 minutes measured from north in clockwise direction. The value is greater than 180 but less than 270 degree. So the line is in southwest quadrant. That means in reduced bearing system, it will be designated as south measured towards west. So to get the value from south, we have to subtract the whole circle bearing by 180 degree. The reduced bearing of line DA would be 259 degree 42 minutes minus 180, that is equal to south 79 degree 42 minutes west. The latitude is equal to L cos theta and departure is equal to L sin theta. Now the values are tabulated as shown in figure. The sum of the northings is equal to 260.81 meters. Sum of southings will be 259.90. The difference is plus 0.91. Similarly, the sum of easting comes out to be 362.46 meters. Sum of westings is equal to 363.10 meter. The difference is negative 0.64. Since the difference between northing and eastings are not equal to 0, it is clear that there exists some closing errors in the traverse. Closing error, as we know, is equal to square root of summation of all latitudes plus square of summation of all departures. It is equal to under root 0.91 whole square plus 0.64 whole square is equal to 7.112 meters. We know that the relative closing error will be equal to closing error divided by perimeter. So the value would be 1.112 divided by the perimeter, that is summation of all length 1049 is equal to 1.943, that is written as 1 in 943. Next question. Given the following latitudes and departure of the sides of a traverse A, B, C, D, E, the bearing of line BC and the length of line CD have been omitted. Because of some constraints, it is omitted. Now this is the table, the line, length, bearings, latitude, departures are given, and as you can see, some of the values are missing, and by checks, the latitudes, departures, everything is to be calculated and the missing values has to be calculated. In the question, we have to calculate the bearing of line BC and the length of CD. In the question, the length of CD is unknown. The bearing of the line CD is given as north 37 degree 36 minutes west. So the length is missing, bearing is known. So what we do, we'll assume the bearing of this line as 0 degree 0 minutes. That is, assume the line to be in the direction of north and south. If we have changed bearing of one line in a closed traverse, then the bearing of all the other lines are also to be changed. With reference to this line CD, which is originally having bearing 37 degree 36 minutes in northwest quadrant. So we will convert it. The bearing of line CD will be north 37 degree 36 west minus north 37 degree 36 minutes west, it is equal to 0. If we draw this sketch, we can easily do this. The north is rotated towards the west and south would be rotated towards the east. So bearing of next line DE, which is given as south 55 degree 18 minutes west, will add the angle 37 degree 36 minutes to get the correct value. When we add it, we get a value that is greater than 90 degree. So south 92 degree 54 minute west should be measured from actually north. So it comes out to be north 87 degree 06 minutes west. The bearing of line EA is given as 2 degree 40 minutes west. We'll add this angle north 37 degree 36 minutes. We'll get the bearing of line EA as south 40 degree 16 minutes west. Since the south is rotated towards east, so the bearing of line AB will be reduced. So the bearing of line AB will be equal to south 59 degree 45 minutes west minus 37 degree 36 minutes west. So the value comes out to be 22 degree 9 minutes west. Now that the bearings have changed, the latitudes and departure values will also be changed as per the new references. So again we will go back to the table and calculate the values of latitudes and departure. Now we will find the latitudes of the line from the known lengths and bearing of the line. The latitude of AB is equal to 78.2 into cos of angle 39 degrees 48 minutes. It is equal to 60.08 meters towards south. The latitude BC is equal to 198 meters into cos of angle 36 degree 24 minutes. It comes out to be positive 159.37, that is towards north. Latitude of line CD is equal to 37.8 meters into cos of angle 21 degree 12 minutes. It is equal to 35.24 positive sign, that means it is towards the north. Latitude of DA cannot be calculated, let it be L cos theta. Now the algebraic sum of all the latitudes. Now let L be the length of the CD, which is unknown, and theta the reduced bearing of line BC, which is unknown as per the question. Then the latitude of BC would be equal to 318 cos of theta, and the latitude of the line CD is equal to L, because cos theta would be 1 when theta is equal to 0. For departure of BC, which is equal to 318 sin theta, and departure of CD would be 0 because the value of theta is 0. So, sin theta will also be 0. Since A, B, C, D, E is a closed traverse, summation of all the latitudes and summation of the departure must be equal to 0. So, we will get two equations, 14.34 minus 132.18 minus 201.42 plus 318 cos theta plus 1 or L is equal to 0. And the second equation, from sigma D is equal to 0, we get minus 283.08 minus 111.96 plus 81.99 plus 318 sin theta plus 0 is equal to 0. Solving the second equation, we get the value of sin theta. We can write sin theta is equal to 313.05 divided by 318. Theta would have two possible values, 79 degree 55 minutes or 100 degree 5 minutes. We will carry on with theta is equal to 100 degree 5 minutes. This is also the reduced bearing of the line BC with reference to assumed meridian, which will be equal to 313.05 meter. The latitude of CD, which is L, we can find from the first equation, that is sigma of latitude is equal to 0. So, solving the value 14.34 minus 132.18 minus 201.42 plus 318 cos theta plus L is equal to 0. We will put the value of theta as already being calculated. The value of latitude of CD L would be equal to plus 374.94 meters. Bearing of line BC with respect to the assumed meridian is 100 degree and 5 minutes. It is northeast. So, the bearing of the line BC with the actual magnetic meridian would be 100 degree 5 minutes minus 37 degree 36 minutes. It is equal to 62 degree and 29 minutes in northeast. That is all for this class. We will hope to continue your learning with us in coming classes. Thank you for now.